Every time a pre-flight is pulled on the F-102A, close to $1 million worth of airplane and the life of a pilot is at stake. That's where you come in. It'll be up to you to make absolutely sure that the aircraft is ready to fly safely. Inspect the landing gear first. See that the ground safety pins are installed on both sides and that both sets of chocks are in place. Inspect the tire for proper inflation and general condition. Check the shock strut for proper extension, the landing light for cracked or broken lens, and the fairing for damage. In the wheel well, check the high-pressure air gauge for the correct reading. In addition, inspect the general area for hydraulic leaks and line damage. See that there are no leaks around the fuel cap and that it is secure. Following this, check the general condition of the armament doors. An inspection of the cockpit is the next step. As you raise the canopy, make sure the seat fins are installed. Then inspect the lap belt and shoulder harness for general condition. Inside the cockpit, check the shoulder harness inertia reel for operation and security. Make sure all switches are either in off or normal. Drop the ram air turbine at this time. Check the oxygen pressure also. The cockpit area should always be inspected for general cleanliness. And don't forget to check Form 781 for discrepancies and aircraft status. Before leaving the cockpit, examine the plexiglass for cleanliness and nicks, and do the same for the windshield. The next check is at the left air intake. Pull the plug and check for any foreign objects or material in the intake. Always notice the general condition of the skin surface as you move along. Inspect the radome thoroughly for any damage or cracks. Do the same for the boom. In addition, make sure the holes in the tip are not clogged with dirt or any other substance. Inspect the other side of the boom and radome in the same manner. See that the static port is free from dirt. Then open up the forward electronic compartment. In here, you will check the anti-ice fluid tank for specified servicing and the filler cap for security. Be sure the access door is secure. The right intake is inspected in the same manner as the left. Examine the front tire for cuts or damage, the shock strut for proper extension, the nose steering unit for condition and lock pin removed, the taxi light for security and condition, and the nose gear door for damage. In addition, you will also check the battery, the ground safety pins, and the circuit breaker panel. When you have finished in the nose wheel well, check the armament door the same as you did on the other side. When you get to the ram air turbine compartment, inspect the blades on the turbine. Then check the hydraulic reservoirs for fluid level. The accumulator gauges for proper pressure, and look for any leaks or line damage. Release the latch and make sure the door shuts securely. In the right wheel well, first check the emergency AC alternator for security, then make sure all circuit breakers are in. The general area is inspected for hydraulic leaks and line damage as before. Check the right gear in the same manner as you did the left. However, an additional check on this gear is to make sure the static wire touches the ground. Following this, make a visual inspection of the leading edge and underside of the wing. Look for dents and fuel leakage. Don't forget to inspect the position light. Make sure the lens is not cracked or broken. Next, check the wing tip. Note the condition of the trailing edge and elevon. At the tail, inspect the skin, the navigation lights, the vertical stabilizer and rudder, and the speed brake area. Be sure to look inside the tailpipe for evidence of fuel and general interior condition. While here, check the afterburner nozzles for security, then make a visual inspection of the drag chute area. The left wing is inspected in the same manner as the right. When you finish inspecting the left wing, the next step is to perform the upper surface checks. On top of the wing, look for general surface conditions, then check the dorsal fin for dents. At the same time, check the various fuselage panels for security. Above all, be sure to remove the Q intake covers and inspect the tubes. They should be completely free from any foreign matter. Make a visual inspection of the right wing also. This completes the power off part of the pre-flight. The majority of the power-on checks are performed in the cockpit. Here you will check for proper functioning of the various switches, lights, and gauges. When you have completed the cockpit checks, do not fail to inspect the engine compartments for fuel leakage. This is necessary, as you will have operated the booster pumps for the power-on checks. When you are satisfied that there are no leaks, close up the panels and sign off the form. This completes the F-102A pre-flight inspection.
December, another phase of TF-102 armament tests was concluded at Holloman Air Force Base. Working in cooperation with Air Force personnel, the contractor's representatives were able to prove out yet another feature of the United States Air Force's only side-by-side transitional jet trainer. The tests were concerned with separation effects of DVA GAR-1 Falcon missiles on the aircraft. Also of concern was the effect on the missile itself when being fired at the supersonic speeds flown by the TF-102. Extensive preparation was made at the contractor's San Diego facility. At Holloman, it's the start of another firing day. Following pre-flight checkout, the aircraft is turned over to the armament crew. The first Falcon case is opened, and one of the 111-pound missiles is set in place for testing. The igniter circuit is checked before the missile is mounted and armed with the igniter. Next, circuits terminating at the umbilical contacts are tested. The two-man loading crew easily loads the first of 6 Falcons and makes sure the bird is properly seated on the launcher. A special tool is used to insert the igniter into the motor. The igniter's wires are then connected to the missile circuitry. The missile is now fully armed and capable of delivering its lethal blow. Downhill firings have been conducted at speeds over Mach 1. Here, however, we see at slow camera speed a firing at Mach 0.9. Having successfully completed the Falcon firing tests, bay doors of the TF-102 are currently being refitted for firings utilizing 2.75 rockets. At the contractor's Fort Worth facility in November 1956, this two-place tandem seating mock-up of the F-106B was on display. In addition to its mission as an interceptor, the airplane will serve as a medium for familiarizing F-106A pilots in the operation of the aircraft's weapon system. The canopy can be raised or lowered from this control switch on the exterior of the fuselage. Cross-sectional area of the fuselage has been increased slightly, and the pressure bulkhead has been relocated to accommodate the second cockpit. A 20% larger heat exchanger was necessitated by increased airflow requirements for a two-man compartment. The F-106B interior arrangement is the same as that of the F-106A, except that the electronic and fuel equipment aft of the F-106A cockpit have been moved to provide space for the second pilot. This mock-up has the side stick configuration in both cockpits. It has been given an artificial feel system to simulate stick feel proportional to control deflection, airspeed, and altitude. A revised mock-up of the tandem trainer was demonstrated the middle of December at Convair, Fort Worth. This one had a modified center stick and a compatible map display or horizontal position indicator. These are proposed for tactical aircraft. Control switches are handy and easy to reach. The side stick was designed primarily to allow space for the horizontal position indicator. It is a terrain map display on which the airplane's relative position is indicated in flight under all weather conditions. Throttle control in both cockpits is on the left, and they are linked together to allow operation from either position. The forward cockpit is identical to the rear one. In both cockpits, the radar scope is directly in front of the pilot and is easily scanned. The canopy control and lock is located on the right side of the forward section. The canopy cannot be raised or lowered from the aft compartment. From evaluations made on this tandem cockpit mock-up, design changes, if needed, can be determined. The F-106B carries an armament load of 1 MB-1 rocket and 4 Falcon missiles. This is the same load as the F-106A. Structural provisions for an alternate armament arrangement consisting of 5 Falcon missiles will be effective on production airplane from number 4 on. Due to increased gross weight resulting from provisions for 2 pilots and their equipment, the combat ceiling and range of this airplane are slightly less than those of the F-106A. However, the top Mach speed of the 2 airplanes is identical. At Edwards Air Force Base, the contractor is conducting ground vibration tests on an F-102A airplane equipped with external fuel tanks. These are a standard tank used by the U.S. Air Force on other aircraft. External fuel tanks would increase the ferry range of the F-102A and reduce the number of refueling stops. They were not specifically designed for the F-102A. The tanks weigh 89.5 pounds empty and have a capacity of 237 U.S. gallons each. These tanks add mass or weight to the airplane and change its vibration characteristics. To conduct the ground vibration tests, the wheels are mounted on spring platforms. This lowers the suspension frequency to a point below the lowest vibration frequency expected on the airplane. Accelerometers on blocks are attached to the wings and body of the plane at various checkpoints. 2 electromagnetic shakers are attached to the wings, 1 at each tip. The shakers are set in motion. The low-frequency shaking, which we see here, is visible to the eye. Shaking is accomplished through a frequency range of approximately 4 to 60 cycles per second. Oscillograph recordings are studied and evaluated. From these and other calculations, the mode characteristics of the F-102A with the external tanks are determined. With ground tests complete and all data compiled and evaluated, the tests take to the air. Many aerial tests are conducted to check further the airplane's characteristics with the external tanks. Among these are the dropping of the tanks to make sure they can be jettisoned safely. The tanks are actually shot away from the aircraft with a shell to get them away quick without damage to the airplane. Other tests consist of installing shakers in the outer aft ends of the wings. With the airplane in flight, the shakers are set in motion. The vibration amplitudes are measured and telemetered to the ground station for evaluation. It is necessary to make from 30 to 40 flights to conduct a complete analysis of the effects of the external tanks on the airplane. Wing tanks are for ferry purposes only. If all tests prove satisfactory, The use of these tanks may be adopted to give the airplane greater cruising range for ferry flights. That's how the MB-1 rocket firing looks to a camera mounted on the right-hand elevon fairing. There is much preparation and a great amount of detailed planning before a firing such as we have just seen takes place. At Holloman Air Force Base, the contractor's test program on aerial firings of the MB-1 rocket is currently in progress. The 1797 F-102 airplane is a standard production model. However, it features a retractable rail launcher designed to carry the rocket within the bay until time for firing. The purpose of the tests is to prove out the airplane's ability to fire this missile within the performance envelope. That is, to conduct tests on the complete firing sequence at various altitudes and at predetermined speeds. Special instrumentation used in the tests is calibrated prior to a test run. This instrumentation includes 4 26-channel oscillographs used to record flight characteristics, a 12-indicator photo panel, which repeats instrument indications in the airplane, oscillograph equipment, which measures blast forces and aircraft response. Many other pieces of equipment are used, such as 6 in-flight recording cameras. They are used to record the actual firing of the MB-1 at the moment it leaves the launching rail. The cameras are mounted at various vantage points on the airplane to secure the best coverage possible. The cameras are loaded and made ready for flight. Last-minute adjustments to the sensitive equipment are made, and the airplane is ready for its run on the firing range. Control for the flight is provided at Radar Vectoring Station King 1, where radio and radar contact with the airplane is maintained. As soon as the plane is airborne, the radar crew goes into action. Their job is to pick up the path of the airplane and then lock on. Meanwhile, in the interior of the building, the various crews are all working together and feeding information to the 2 men at the vectoring station. The course of the airplane is clearly shown on the chart, and from this information, the engineer in charge of the run talks to the pilot and gives him accurate instructions so that he may get into position for the firing on the predetermined range location. The engineer is in constant communication with the pilot, keeping him on course. A test firing such as this one requires teamwork, and teamwork there is. The flight plan is worked out in detail prior to takeoff, and the object is to vector the F-102 to the correct line of flight over the 38 by 128 mile firing range. By means of radar, the airplane position is indicated on this vectoring chart, which actually looks like this. The dotted red line indicates the airplane's exact position on the range. Each of the dashes indicates so many seconds. From their movement, the plotter can tell the exact position of the airplane and relay this information to the engineer on the radio phone, who in turn keeps the pilot on course and moving into firing position on the range. As the airplane approaches the firing point, the engineer on the ground goes through a final check with the pilot on the aircraft and instrumentation configuration of the airplane, then starts his countdown.
7, 6.
Cameras are turned on, and all other switches are activated for the release of the rocket.
2, 1, fire.
From the camera's eye on the airplane, it looked like this. Upon completion of a firing, the F-102 returns to Holloman, where oscillograph and camera records are processed for evaluation. The aerial firings of the MB-1 on both the retractable rail launcher, such as we have just seen, and the downward ejection system are proving out well.